Alright, so I've been using accelerated C++ to supplement the course I'm currently taking. I don't like the textbook in that course as much. This was recommended to me, and so I gave it a shot, and I've really been enjoying it. I'm going to tackle a problem in it today, and that problem is 3-3. So what we got here, this was the chapter on vectors, and vectors were particularly interesting to me because I'm more familiar with Python and JavaScript, and the idea of vectors isn't present in those languages. It's, I guess, done through arrays and objects. Anyways, so problem 3-3. Write a program to count how many times each distinct word appears in its input. So obviously this is going to force us again to use vectors. So let's get going here. I'm using dev C++. I was recommended code blocks, which I am using on my own, but this was the compiler required by my course, so it's what I have up right now. And we need to start off by including libraries, so include good old IOStream. Then let's go ahead and include, we're going to need vectors, like I've already stated. Our vectors are going to be string based, so we're going to need to include string and include, we're going to need to include algorithm as well, and you'll see why. And then our using statements. Alright, got that out of the way. And now, of course, we need to initialize main. And let's get me set up here. Alright, I'm going to start by explaining the program. Explain program. And I'll go ahead and state that we're going to request input to minimize some amount of comments. See out here. Well, maybe I should use their words. Write a program to count how many times each distinct word appears in its input. So this program counts the number of distinct words, period, and that, and L. Perfect. Alright, and now we're going to request our input. Cout, enter a statement, because I guess it doesn't necessarily need to be a sentence, and I'm on Windows, so we're going to need to, and then we're going to need Control Z when done. And we'll have that appear on a new line just for formatting's sake. Good. Let's go ahead and declare variables we're about to use. We're going to need a vector, obviously, a vector which will be a string vector for the statement, and I got very creative here. Let's say it's called statement. Perfect. And string to go into our vector, and we're just going to call that a word. Alright. Wall input each word into our statement vector. This I found interesting because the way it worked, it's detailed in the chapter that, well, in an early chapter, that C++ uses spacing to dice up strings. So a string ends at the space, which makes it possible to do this wall statement. Wall cn word, and then we're going to have each word be read into statement with our pushback method. Oops, pushback. And so as the user enters words, the wall statement will read those words in, and at each word, it is going to push it back into our statement, which is pretty neat. Okay. Alrighty. Let's go ahead and use. Well, we will need to have the size of our vector. In order to do this, we're first going to use type define like they do in the chapter. So we'll just explain this real quick. We use type define to create a synonym walk. A synonym for the given type. Type def is not creating a variable, but a shorthand way of writing vector string size. Oh no, are we going to go over the line? We are. I took a bit more notes on this in particular because it was new. I wasn't aware of something like this in Python, and I wanted to make sure I was thoroughly comprehending it. Now we can just write back as the. And then let's end our longer comment. So we're going to be using type define, which is going to allow us to use the size type for our vector string with kind of our shorthand, which we'll be doing now. Type define vector string, and then size type back size was our name for it. Alrighty, and then we're going to implement this, or we're going to put this to use immediately with this statement. And then we can use a word count right here just to make sure everything is getting inputted into size. Everything's coming out right. There we go. Alright, so now we're going to have type define vector string size type vec size is now declaring that vector string size type. So I'm using vec size, and now size is going to equal the statement size. And then we're going to output it just to make sure everything's flowing correctly. And at this point, we need to make sure that words are actually inputted, because if the user does not enter a statement, we're going to need to alert them to their error. So if the size equals 0, we have a problem, obviously. Let's go ahead and close that. So if the size equals 0, let's say let's make sure we go down a line from our previous code. Error. You must enter words. Poetic, I know. And then we can go ahead and return 1. Because this won't be a programming error, this would be a user error. Alright. And now we can move on to the else statement, which will be if they actually entered words. So else, if something was entered, dot dot dot, and else. Good old else. It's when tackling a new language, especially with someone who doesn't have extensive background in a ton of languages, it's nice to see familiar words. There's always familiar statements and familiar functions, but it's particularly nice when the words are even familiar. So we're going to need to sort. Let's explain what we're doing here. We're going to sort is used to put the strings or the words entered in non-decreasing order. And that was a fun thing to read about. We say non-decreasing instead of increasing because some words might be the same. I guess that would make more sense with numbers, whereas this will just be doing it alphabetically, but regardless. Alright, so let's go ahead and sort, which was also explained in this chapter, and I'm going to sort my statement dot begin, and then statement dot end. Once sorted, let's go ahead and initialize a counting function so we can keep track of actually how many words will be in our statement, and we're going to need a for loop here. I had done 3 weeks of CS350 during winter break. I meant to do all of CS350, but that was a bit ambitious. However, CS350, of course, is Harvard's Intro to Computer Science, and it is entirely using C and for statements, I guess with C++ being built on top of C, are identical. So that is nice, and it's also reassuring. Knowledge going to work. What? Let's see, what's this guy from? This is from my else. That's from my if. Where are you from? I wonder if that was originally intended for my if. I assume so. We'll see if we get errors. It's always a fun... Oh, of course, it's for my for statement. Got it. Alright, for. See out. Let's see. No, I mean, we don't... What we need to do is count. So I'm going to need an if statement. If statement I is not equal to statement I plus 1, then we want to go, well, we want to increase our count. We want to keep track of how many unique words. So then let's increase that count. And what in the heavens? Okay. And then that should actually get us home right there. So see out. Now we're going to need to tell them how many words we got. So amount of non-repeating words. Let's give them the count and L. And we're going to need a system pause. Don't want the user to think it's part of my code. System pause. Return 0. Well, it's looking good. Let's see what happens here. So let's go to execute. Let's compile and run. Ooh, that looks fun. String has not been declared. Oh, using, yikes. Typing too fast for my own good here. Okay, that one we got. Well, let's see what happens. Oh, okay. Enter a statement, then Control Z. This is a statement. Yes, this is, how many words do I have there? 1, 2, 3, 4, 5, 6, 7 words. I'm repeating myself twice though, so that would be 5 distinct words. Let's see what happens. Control Z. Word count is 7. 4. This is 1, 2, 3, 4, 5. Well, we have a problem. Let's figure it out. This is the fun part. Aha! Counting at 0 is going to be an issue because we are not considering our last one. If you notice size, you're not comparing the last one to anything but the thing next to it. So we will need to actually have a count of 1 already included in our count, because there will be one word, and then our size is size minus 1 in our loop here. Let's go ahead and give this a shot now. Hello there. this works. There does it. Alrighty. 1, 2, 3, 4, 5, 6, 7 words. One repeats itself. So 7 words, 6 distinct. Control Z it here. Aha! Let's try it again. Hello there. So we have 6 words. We only have, I believe, 3 distinct words. Let's see how we do. Control Z. Excellent. So our issue was just our initial count again. Having it as 1 is critical, especially since I'm using the I for my loop. When I equals size minus 1, it's going to stop, meaning it will only look at the final object over here. The final object won't obviously be over here because that would be an issue. If my final word was there would have nothing to compare it to. So it looks at the word right before there. Maybe that's hello there. So it would look at hello, and then it would be comparing that to there. If it falls into the if statement, which it would only be counting up 1. So if we started by 0, then we would only get a count of 1. But even if my statement was hello, hello, it would not fall into the if statement where it would be needed, because if I started my count at 0, we would need to record that there's actually 1 distinct word. Count would need to be started at 1. And that's my solution for this problem, an accelerated C++ 3-3 with vectors. I'm sure there's a million ways to solve it, and probably more efficient ways than I have. But that's what I came up with, and hopefully as I progress throughout this chapter and throughout these videos, my code will become more and more efficient and clear.